There are three key definitions that you're going to need to know in order to properly understand acids and bases in organic chemistry. We start with arguably the most important, the Bronsted Lowry acid and base. These exchange protons, or H+. A Bronsted Lowry acid is a proton donor. A Bronsted Lowry base is a proton acceptor. And when an acid and base reaction occurs, what we have is a proton exchange. In this example, I've highlighted the proton that's moving in blue. We have a hydrogen atom here that is part of the acid because it is the donor. This base can come in and abstract that hydrogen, and you'll notice that it is being exchanged from one species to another. The acid or proton source will form something called the conjugate base. The base, or proton acceptor, will form something called the conjugate acid. You'll note that in Bronsted Lowry acid and base chemistry, we start with two species and we end with two species, where they literally just exchange a hydrogen atom. So Bronsted Lowry is all about proton exchange, hydrogen from one species to another. Let's look at our next definition. So an Arrhenius acid and base do chemistry in a very specific environment, water or aqueous conditions. An Arrhenius acid is a proton donor, and an Arrhenius base is a hydroxide donor. Now, it's worth drawing your attention to something very important here, and that is that these definitions are pretty out of date, and for that reason, not used anymore. In your organic chemistry courses, you will need to have a baseline understanding of what these definitions are, but you're only going to see Bronsted Lowry acids and bases and Lewis acids and bases in action. Here we take a look at an acid, HCl being a proton donor, and here we have water serving as a hydroxide donor. So again, Arrhenius is all about the proton and the hydroxide, but the definitions are quite out of date, which is why we focus on Bronsted Lowry, because that is done in non-aqueous conditions as well as aqueous conditions. Let's look at our last definition. So a Lewis acid and a Lewis base is all about electrons. Lewis acids and bases are electron donors and acceptors. It's for this reason that this definition is less common in organic chemistry, but you will still see it occurring, especially when you start to talk about activation of electrophiles. A Lewis acid is an electron pair acceptor, and a Lewis base is an electron pair donor. The classic Lewis base is going to be something with a lone pair. Here I've shown nitrogen, but nitrogen and oxygen are really common Lewis bases. The other most common Lewis acid is going to be boron, because boron is sp2 hybridized, and for that reason has a vacant p orbital, which makes it an excellent electron acceptor. Also worth noting is that anything in the same column with boron is a good candidate for this. Aluminum is another really common example for a Lewis acid. So a Lewis base has a lone pair of electrons, and a Lewis acid is an electron acceptor. They come together and form a new bond here. You'll notice we've introduced some formal charges. The nitrogen is now positive and the boron is now negative. Now, I want to draw your attention to something really important here. When we saw the Bronsted Lowry acids and bases, we started with two reactants and made two products. In Lewis acid and base chemistry, you start with two reactants, but make a single product. And that's a really good way to identify that Lewis chemistry is occurring. So, three main definitions: Bronsted Lowry about proton exchange, Arrhenius about proton or hydroxide donation, and Lewis acid and Lewis base about electron sharing between donors and acceptors. You should be comfortable both with providing a definition and recognizing the chemistry of all three types of reactions.